Hello guys, welcome to my channel Data Services. So in this video we are going to see how we are going to create a CAD model for a slider crank mechanism. So slider crank mechanism is also called as a 4-bar mechanism. This is called as 4-bar mechanism since it is as a 4 linkages. So these 4 linkages are used to convert the sliding motion to the rotary motion. So we'll see what are the parts going to get involved in this. The first part going to get involved in the slider crank mechanism is the crank, which is also kind of a wheel. The second part is small linkages, which is going to connect with the crank and the wheel. The third part is a large linkage, which is going to connect between the small linkage and the slider. And the fourth part is a slider, which is a kind of a piston cylinder arrangement or can be as a sliding motion. So by using these 4 parts and 4 linkages, we are going to create a slider crank mechanism. The application of this principle is mainly based on the IC engines, where the sliding motion is converted into a rotary motion. So without any delay, we'll get into the parts. As same as the previous videos, this video is also going to contain 3 different sections. The first section is going to demonstrate how to create the parts of the slider crank mechanism. And the second section is going to demonstrate how to create an assembly for this. And the third section, we are going to see the mechanism simulation and how the mechanism is going to work. So we'll start from the first part as a wheel. So I'm going to click on the new button. I'm renaming it as a crank and click enter. So a part has been created. I just go to the extrude and I'm selecting the front plane and moving to the sketch view here. So the profile is going to be in a circular motion. So I'm going to add a center line on both horizontal and vertical directions. In this coincident 0,0 point, I'm going to draw a circle with a diameter of 100 and just click OK here. The thickness of the wheel, I'm going to have it for the 10 mm, which is in the symmetric motion. So select the symmetric and click OK. So this is the wheel which we are going to have as a crank. The next thing, I'm going to add some other cutouts in this to have a better strength for the wheel. So for that, I'm selecting the extrude option and selecting the front surface of this wheel. Moving to the sketch view, I'm going to have a circle in middle which is equals to the diameter of the shaft. The diameter of the shaft or the pin which I'm going to use it here is for 10 mm. Apart from this, I'm going to use some other profiles which is obviously needed for the strength and the material. So I'm going to have a pitch circle diameter of 70, and in the pitch circle diameter I'm going to have 4 different holes which is also equals to the diameter of the whole shaft as same as 10 mm. So once this is done, I'm just going to click OK here and I'm reverting the material direction, so automatically the remove material will get enabled and the material is removed here. I'm going to have some other profiles to have better strengthen of this material, so that I'm selecting extrude option once again and going back to the same surface. Look on the sketch view. I'm going to have the same PCD of 70 mm diameter. And I'm going to have a profile of radius 5 or the diameter 10 between 2 circles. The angle profile of this circle I'm going to get coincident from the center line as the angle of 30° for the both. And next I'm going to create a center point arc to connect the edges of these lines as same as for the bottom one. I'm going to delete all the unwanted lines here. So this particular profile I'm going to pattern it on based on the axis. So I'm selecting the pattern feature. Based on the type, I'm going to select the axis And for the axis, we already have a line here. Okay, to enable that, first I need to enable the axis here. In view, I'm enable the axis. Next, I'm going to select this extrude, moving to pattern, and in the type, I'm going to select the axis. So I'm selecting the center axis as the references, and by default it's selecting four quantities, and the angle between each quantity as 90 degree. Either it can be as same, or if you wanted to use as angular event, h is equals to same value, and you can click OK here. So here you can able to see a perfect crank wheel has been designed. So this part I'm going to take it directly. The next part I'm going to create a link between the crank and the second one. So this is called as a small linkage. I'm going to rename it as small linkage and click OK. To have a small linkage, I'm going to use a racetrack design concept, so that I'm click extrude here, select the front plane as a surface references, and moving to the sketch view. I'm going to create a center line on vertical as well as horizontal. Next, I'm going to go for the palette option. In palette, we have some defined shapes, which is like polygons, profiles, shapes, and stars. In this, I'm switching to the shapes. In shapes, we have ace, arc, racetrack, cross, oval, racetrack, rounded rectangle, wave 1 and wave 2. In this, I'm going to use racetrack concept. So I'm just drag and drop the racetrack profile here. Just click OK in this, and I'm going to make coincidence with this center one. Okay, first let me modify the dimensions. This I'm going to take it as 20, and this I'm going to take it as 300, and I'm going to coincidence the line of to make it as 0, and this distance is considered as 300. So on the horizontal way also I'm going to coincidence with this line, and just click OK here. The extrude width of this linkage is going to consider as 10 mm in the symmetrical way. The next thing, I want to add a hole here. So for that, I'm going to enable the axis first, and I'm going to create two axes. One is on this circle area, another one is on the opposite side of the circle area. So in this, I'm going to have a axis to be as enabled. Now I'm going to create a hole. To create a hole, I'm selecting the hole command. I'm selecting this axis line along the surfaces. The diameter of the hole is considered as 10 mm, which is equals to the shaft hole diameter, and the depth I'm going to have until through hole. Just click OK. The same way, and hole in the opposite direction also has been enabled through all, and click OK. So this is the profile of small linkage which we have in the slider crank mechanism. The next I'm going to have the same kind of a part, but it's a large linkage. So I'm going to have large linkage. I just click OK here, and I'm going to follow the same step procedure. Click on extrude, select the front plane, moving to sketch view, and I'm going to draw center lines. In this, I'm going to use palette option, and in profiles, sorry, in shapes, I'm having a racetrack profile. So just click OK here. Directly you are going to coincidences. Okay, or else we'll make it as a dimension as the same as 0, and it's coincidence in the horizontal way. So the total diameter of this is 20 mm, and this total is 600 mm, which is double the twice of small linkages. In case while we are going for a mechanism, if the length of this larger linkages need to be extended or shortened, we can do it in later. Just click OK here, and width is also considered as same as 10 mm in symmetric way. As the same we saw in the previous one, now we are going to have a hole in both the ends. So to have that, I'm going to have an axis on both the ends, and I'm now going to execute the hole command. Select the axis and select the surface. The depth would be considered as through all and click OK. So same way in the left hand side, select the whole command, select the surface, select the axis line, and depth is considered as a through all and click OK. So this is how the large linkage of the slider crank mechanism has been done. So the next thing, we are going to create a pin which is going to connect all the linkages. So for this, I'm renaming it as pin and just click OK here. For this also, I'm going to use extrude option based on the front plane, moving to sketch view, having a center line on vertical and horizontal. This will make it a coincidence. Now we are going to have a circle option here, which is the diameter is 10 and the extrude length is 22 and the depth profile has been symmetry. Diameter as 10. So we have created a pin which the diameter is 10 and the length is 22 in symmetric. So the last and previous part, we are going to create a slider which is also a kind of a cylinder. So next we are going to create a slider part which is more similar to a cylinder of an IC engine. So to create this, I'm going to use a revolve command, selecting the front plane and just moving to sketch view. For this, I'm going to use the diameter as 60 mm of the external cylinder dia. I'm making an axis line in the vertical and center line in the horizontal. So this is the diameter, internal diameter, external diameter, height of the cylinder and thickness of the cylinder. I'm just moving to modify all these dimensions now. So internal diameter of the cylinder I'm considering as 50, external diameter of the cylinder considering as 60, and height of the cylinder I'm considering as 60, and thickness of the cylinder I'm considering as 10. Just click OK here. Now I'm going to have a small profile where the piston rings and the oil rings will get assembled here. This distance I'm considering as 1.5 as the same value I'm going to give for here. And another piston ring, and another one is for oil ring. All the dimensions I'm following as same as 1.5 in the previous one. I'm deleting all the unwanted lines here, and here we have a sketch of cylinder. Just click OK here and we can able to see as cylinder kind of a structure and a slider has been created. Now I'm going to create another extrude to have a hole in this. So select the extrude, selecting the front plane, moving to sketch view. Here I'm going to have a circle for the diameter of 10 and the depth is 25 mm. Just click OK here and extending this length in the both directions, which is going to be as a symmetry, and going to click on the remove material, so the material is removed. I would like to reduce the height of the hole position from 25 to 20. So this looks good, and this I'm considering as a cylinder which is a kind of slider content. The last and final part, we are going to create a cylinder base where this piston moves up and down. So I'm just selecting this, I'm converting this as a cylinder. Just click OK here. And the same as piston, we are going to use this as a revolve command. Selecting the revolve, click on the front plane, moving to sketch view, and I click on the center line, axis line on the vertical and center line for the horizontal. So here I'm going to have a cylinder construction where the internal diameter of the cylinder matches to the external diameter of the piston. So the value of this internal diameter is 60 and the external diameter is considering as 70. I'm going to have this length as 180 and the internal thickness as 170. Sorry, 170. Just click OK here. So a cylinder kind of a structure I have created. Just to have a better understanding on this, I'm going to change the appearance of this particular material as a glass structure. So this will be becomes kind of a transparent where we can able to see the piston moves up and down whenever we are running the slider crank mechanism. So this is guys how we are going to create all the parts step by step. I would like to show all the parts, each and every parts one by one. So this is a cylinder which is going to be as a stationary connect. The next one is as a slider, which is a kind of a piston engine, piston kind of a thing. The next part is a pin, which is going to get linkages between each and every parts. And the next part is a large linkage. And the next part is smaller linkage. And the first part is a crank, which is kind of a wheel in this. So the next section of the video, we are going to assemble the parts for the slider crank mechanism. So the first part which we are going to assemble here is crank. So before getting into that, I would like to have a axis lines for the planes. So just select the right and top, make an axis line, top and front an axis line, and right and front an axis line. So here we can able to see we have three different planes, a coordinate system and three different axis lines. So we are going to start the assembly, click on assembly and to insertion, I'm going to select the crank. So crank is the first part which we are going to assemble in the slider crank mechanism. Please make sure to assemble this crank, we are going to use pin connection. So pin connection enables us to make the mechanism simulations. So I'm going to type, I'm selecting the pin connection, I'm selecting the axis here to the axis which we have created in assembly file. And in translation motion, I'm selecting the front plane of the crank to the front plane of the assembly. So here we have created a pin connection for the crank. So the next part, I'm going to assemble the pin. Click on assembly, insertion, I'm selecting the pin. So pin is another part which we are going to have in the same pin connection. Since this part is not going to affect any kind of a mechanism simulations, so we can directly assemble this in the user defined or rigid way. I'm going to select directly the axis line to this axis line as a coincidence, and I'm going to give coincidence between the edge surface to surface of pin and crank as a coincidence. So this is how the pin and the crank has been get assembled here. So once you assemble the crank and the pin, the next part which we are going to assemble here is the smaller linkage. So for that, I'll just, before getting into the assembly of the smaller linkage, I would like to hide the crank so we'll have a better understanding of this assembly. So we're going to click on the assembly button, insertion, I'm selecting the smaller linkage. So since smaller linkage is also going to have a mechanism movement, so make sure we are going to use pin type connection for this. So I'm selecting the pin type connection. I'm selecting the axis of smaller linkage to the axis of pin. The next translation, I'm going to select the surface to the surface of the pin and to be as a coincidence. Now you can enable the crank and you can able to see there is a minute gap between the crank and the smaller linkage. This is why the reason we have given the extrude of the pin as 22 mm. The gap between the crank and the smaller linkage is 2 mm. So the next part, we are going to assemble once again the pin in the opposite side of smaller linkage. So select the pin. This is not going to have any movement, so we can just select directly, click here. In case if you have any queries or doubts whether it's going to work, not an issue, you can go for pin connection as well. Nothing will change in the mechanisms. So just select this and select this, just click OK. So the pin in the smaller connection second end is also has been connected. Next we are going to connect a larger link. So insertion, select the larger link, and for the larger link make sure you want to give only the pin connection since it is going to have a mechanism assembly. So select the axis in larger link to the axis in pin. And for the translation, select the surface of the pin to the surface of the linkages. Now we can able to see in the front view a plane has been there, and in the top view also we can able to see the plane in the assembly front plane is slightly offsetted to the larger linkage. The gap distance between these two planes is considering as 24 when we have measured it. So we are going to have another offset plane from the assembly front plane for the value of 24. So select this, create a plane with 24 offset in this. Now we are going to have another axis line which is going to intersect between the datum which we created now and the assembly top plane. By selecting these two planes, you can able to create an axis here. So axis has been created. The next part which we are going to assemble here is the cylinder pin which is going to connect in this another edge of larger pin. So select this, click on the assembly, select the cylinder pin, and for the cylinder pin also we are going to give a pin connection. Select the axis to this, sorry, this, and the translation is given to be as surface to surface with the value of distance 25 Since the total length of the cylinder pin is 60 and the height length of the linkage is 10, so we are going to reduce this. 60 minus 10 is equals to 50 so 25 on each side. The next part, I'm going to create an assembly of cylinder which is going to get a rigid connection, since this particular part is the only part which is going to have a complete arrested of all degrees of freedom and a perfect rigid connection. So I'm going to select a rigid connection here. For the first connection, I'm going to give constraint between these axes which we have created. The second connection is for the rotational motion. I'm going to give a parallel to this plane, or to be as a coincidence or coincidence which won't work. I just wanted to have it as a parallel. This should be as a coincidence of axis to axis. And the third connection, we are going to constrain the distance from surface of the plane to surface. This value I'm going to have it as 750 or else we can even have it as 800 would be better. So this is how the perfect rigid cylinder connection has been done. The last and the final part which we are going to assemble here is the slider. Slider will have two different types of connections. Let us see how it is. So I'm selecting the slider part. In slider part, we are going to have two different types of connections. One is slider connection and another one is pin type connection. First, we are going to have a slider connection. So select the slider. Here we are going to have a assembly between axis to axis alignment. So I'm selecting the surface to the cylinder surface, which will be as a coincidence. And to control the rotational motion, I'm going to select the front plane of the piston to the front plane of the cylinder. So now the slider connection has been constrained. Only the piston can able to move in this direction. That particular degree of freedom has been kept it as free. The next connection which we are going to assemble here is for the cylindrical pin. But before that, I would like to confirm whether it is perfectly assembled or not. Yeah. So I would like to go for the edit connection of the slider. Oh, sorry. I'm going to click on the edit connection of the slider. Next, I'm going to have a new set of connection, which is a pin type. And for this pin type, I'm going to have a connection between the cylinder to pin. Let me move this piston completely outside of the cylinder so that we will get a perfect one. First, I'm going to click on the translation so that I can control the rotation motion first, selecting the front plane to the front plane of pin here. So for that, I would like to hide the cylinder, and I'm select the larger linkage to be also hide. Select the front plane of this, and in axis alignment, I'm going to select surface to surface. Oh, sorry, this is not the surface. For I'm going to select this surface to the surface to be as a coincidence. So the connection is perfect. So the connection is perfectly executed. Now I'm enable the larger linkage as well as the slider. So now I will enable disable the all the planes, access everything. Now we can able to see the first part which we have assembled here is the crank. I'm going to give color it for in steel color. The second part which we have assembled is the pin, which I'm going to give the black color. The third part is a smaller linkage that I'm going to give it in yellow. The fourth part is also pin, which is already we have given in the black. The fifth part is a larger linkage, which I'm going to give it in green color. And here for the cylinder, we have already given the glass texture, so it is being as a transparency. Next, I'm going to have for the cylindrical pin in red color. And the final part, piston or the slider, let it be in the same color. So this is how a slider crank mechanism assembly has been done. So I hope you guys has been understand this. The next session of the slider crank mechanism is mechanism simulation. Let's get into that. So for that, I'm going to switch to mechanism assembly, sorry, applications, and click on the mechanisms assembly. So in this, I'm going to have a servo motor which is going to be have a, for the crank position. So select the servo motor, apply it to the crank position with the profile details as angular velocity with the velocity value of 2 degrees per second. I just click OK here. Just find how the faster it works. In case if you need to have much more faster or slower, you can modify the value of angular velocity which we have given in the servo motor profile details. So next I'm going to click on the mechanism analysis. I'm going to have a start time as 0 and the end time as 100, and just click on the run command so that you can able to see how the slider crank mechanism is to work. Since the speed is very slow, let it run, and once it does done, I will modify the profile details of the angular velocity and will make you to show how it much faster it works. But even in this video you can able to see that whenever the slide crank in the edge, the left end is being rotating, it obviously pulls the smaller linkage pulls the larger linkage pulls the piston towards outside of the cylinder. I would like to modify the dimensions of the cylinder alignment with this distance to reduce at 700 mm or it could be a 750 mm. I just click OK, and I'm going to have this connection once again. So I'm moving to this assembly mechanisms, and I'm going to change the value of servo motor. With the profile details, I'm going to have velocity as 20 degrees per second and click OK. Going to mechanism analysis, start time is 0, end time as 100, and click on run command. So here you can able to see how the slider crank mechanism is going to work. Since the length of the smaller linkage is very high, obviously it is almost to the 300 mm, the piston is to move until the edge of that. So in this way I need to go to the modify the smaller linkage length and to reduce the length of it. I will showcase how to make it. So the thing is, I'll just close this, move back to the part level and select this smaller linkage and reduce the length of this. I'm going to half of the value of this 150, and I'll just click on the regenerate. Entire system will get regenerated automatically. And also I'm going to modify the dimension constraints of this cylinder as 500 mm and just click OK in this. Okay, it's hitting to the edge of this, so let me have it as 600 mm and just click OK. Now go back to the applications, click on the mechanisms and modify the velocity even more little bit faster as 35 degrees per second and click on the mechanism analysis, click as the end time as 100 and click on run command. So here you can able to see how the slider crank mechanism is perfectly working for the system. I need to increase the length of the cylinder, but this is fine, I hope, for this mechanism. And this is how the slider crank mechanism or the 4-bar mechanism is going to work in the applications. So I hope you guys you have liked this video and you have understand how the parts is going to be created, how the assembly is going to create, and how the mechanism is going to work. So if you like this video, please like, comment and share, and also you subscribe to the channel and also share with your friends who are is very much interested in mechanical designs, especially in the Creo CAD practices. As well as in future, I'm going to give some videos and tutorials in SolidWorks as well as in the CATIA. Will so please get into touch and also follow up the channel. So guys, thank you and thank you so much for your support. We'll see in the next video. Bye bye.